3.28 is a serious problem, but it illustrates a lot of things we do. And please stick with me. I know this one's going to feel really complicated, but stick with me because I think it's fun and it's worth doing together. Okay, so here's the point. You've got a dog, and the dog's sitting here on land, and then its toy was thrown out in the middle of the water. And so the dog is going to run across the land, and then at some point jump in and go to the toy. So notice a couple things. One, the dogs run a lot faster than it swims. So the dog runs at about 35 feet per second and swims at 10 feet per second. Okay, so that means that if the dog, so one thing the dog could do is run all the way here until they get to a right angle and jump in and swim to the toy. But you go, well, that's going a little bit further than necessary, so maybe the dog needs to take a shorter distance and just go straight to the toy and jump in and swim all the way. But then the dog is traveling slower the whole time. So it turns out that the best plan for the dog is to run along the edge, and then at some point, whatever that appropriate point is, jump in and swim to the toy at a point that reduces the amount of time it takes. So what we're going to do is we're going to try to solve this problem, and we're going to solve it together. And the way I'm going to solve it is I'm going to call this value right here x. And then we can see we have an x, and that's actually the only variable we need in this problem. Actually, there's one other variable. There's x, and then there's this distance right here, which is d. So let's figure out how long it takes the dog to make this trick. So the time spent, and let's see. So the first thing you have to do is let's call this distance here L. And so what you'll notice is that you need to take L, which is the distance that the dog ran this direction, and divide it by 35 feet per second. So however many feet, this is feet divided by feet per second, and so that gives it in seconds. And so it's plus this distance, d, divided by 5, which is our 5 feet per second. Now what's nice is both d and L can be written in terms of this one common variable, which I will call x, because we can see really quickly that L is simply 20 minus x, and d is, well, we'd have to do the Pythagorean theorem, but d is the square root of x squared plus 25. So d is a little bit challenging, but we can make this happen. Okay, so what is this problem? So this problem turns out to be 20 minus x over 35 plus the square root of x squared plus 25 all divided by 5. Okay, so this is our time spent equation right here. And so this is the equation that we now want to find the maximum of. So what does that mean? It means we just take the derivative and go for it. So let's call that t. And we'll take the derivative, and we'll call the derivative t prime. Okay, so t prime, this first part is, it may look really complicated, but notice it's the same as a constant, 20 divided by 35, minus 1 over 35. So this is just negative 1 over 35. You could have done the quotient rule or something like that, but it's really completely unnecessary. Just negative 1 over 35 is what that is. Let me go into just for a second, because I notice some of you are still thinking a lot about these things. So one way of thinking of this is when I see 20 minus x divided by 35 is thinking of it as 1/35 times 20 minus x. That's the same thing. And notice we could think of this as 20 divided by 35 minus 1/35 x. And then you'll notice this becomes 0 when you take the derivative, and this becomes just that negative 1/35. So hopefully that's not impossible to find out. And the second part is going to be similar in that we have a constant 1 over 5, and so this is like 1/5. And so that second part, think of it as 1/5 times the square root of x squared plus 25. Okay, so if I'm going to do that derivative, it's going to be a little bit more challenging. So let's write it as 1/5, and then we need to do a chain rule because we have an inside part and an outside part. So here's the chain rule. So to do my chain rule, I'm going to start with the derivative of the inside, which is 2x, and the derivative of the outside, which is 1/2 x squared plus 25 to the negative 1/2. So that's my t prime equation, and now all I have to do is I have to figure out when is that derivative equal to 0. Okay, so let's set this equal to 0. And if I set this equal to 0, the first thing I'm going to do is, let's just put a 0 here. And then this is what I want to do my algebra on. That's a little messy. There's a lot going on, but I think we can make it happen. So first, let's add 1/35 to this side and get a positive 1/35 equals, and then let's put all these together. We'll put these, cancel these 1/2s out. And if you look really closely, you'll see that I have an x in the numerator, and on the denominator, I have 5 square roots of x squared plus 25. So that's what I've got on my denominator. Okay, and so what I'm going to do is let's just multiply this over here to make life a little bit simpler, and that'll give me 5 square root of x squared plus 25 divided by 35 is equal to x. Okay, so we're still working on this algebra. Let's go ahead and slide another piece of whiteboard in here so we can keep working on it. These 5's cancel, and we've got the square root of x squared plus 25 over 7 equals x. And now simply I'm just going to square everything to get rid of that square root. And on the left, that's going to give me x squared plus 25 divided by 49. And on the right, it equals x squared. Okay, now I'm getting close. Let's multiply our 49 over. X squared plus 29 equals 49x. And now let's subtract an x squared. 25 equals 48 x squared. X squared is 48 divided by 25. And now I'm able to find my final answer. Now I'm able to find my final answer, which is x is equal to the square root of 48 over 25. And if I want to put that in my calculator, I can see it's really close to the square root of 2, so about 1.4. But let's do this exactly and figure out what it is. So I've got 1.385. So 1.385. So x equals 1.385. So what does that mean? That means that our dog that was going to get the toy, what should the dog do? The dog should run about 20 feet, and then about 1.3 feet before he reaches the right angle, he jumps in and swims. Or she. It doesn't have to be a male dog. Okay. Hopefully this solved the problem, but I want to tell you why I like this problem. I like this problem because there was a mathematician a while back who had a dog who did exactly this and loved to go get its toy out of the water. So he'd throw the toy in the water and the dog would run to it. And he was curious at how well the dog could do at this. So he recorded the dog over and over again doing the same problem and tracked every time how far the toy went and where the dog jumped in, and then measured how fast the dog ran and how fast the dog swam, and then compared the dog's jumping in point. So you've got where the dog jumped in, the dog's choice, versus the calculus solution. So if you think about it, there's calculus tells you where the right point is, and then there's where the dog chooses in. And what was so much fun about the problem was that these two ended up being virtually equal. And that is that the dog consistently chose the point that calculus would say is the best point to jump in. Not always exactly, but usually pretty close. And so this led him to ask the question, can dogs do calculus? And I don't think the dog is actually doing the problem the way that we're doing calculus here. But what we find is that nature has put inside of us, and as a Christian, I believe this has to do with our created being. But nature has put inside of us processes which learn how to optimize things and speed up time. And so we can naturally optimize problems. Even dogs can naturally optimize problems. that it's quite hard to do doing calculus. Well, I hope that story was interesting. We've got one more problem. It's not near as hard. This problem is a degree beyond anything that I'll ask you to do in the homework or the quiz. Our last problem is all about building a shape, and this one is the type of thing that you'll do on your homework and possibly a quiz. Right, so try 3.29, and then I'll see you there.